This is Algebra 2 with Trig. This is the Semester 1 exam review. This is starting with page 3. Page number 3. So we're going to look for which of the following represents a function. So to do that, we need to know that each x goes to 1y. So when we look here, we see that 1 goes to -1, 2 goes to 5, but 2 also goes to 7. So those are going to different numbers. So we know that that's not it. -1 goes to a value, 1 goes to a value. They happen to be the same value, but that's fine. 2 and 3, so that one's looking pretty good. 2 goes to 2 different values here. And 4 goes to 2 different values. So C is the best answer. We're going to choose the inequality whose equation is a solution here. So first of all, we need to come up with the equation. So it looks like we're crossing here at -2. So I have a b value of -2. I have a slope. It looks like I'm going up 1, 2, 3 over 1. 1, 2, 3 over 1. So it looks like my slope is rise over run of 3. So y equals mx plus b. But that's not the format that they have here. These are all in standard form. So they've moved the x across. So they have -3x plus y, and they have the -2 on that side. These are also inequalities because there's shading going on with the graph. Notice that they're shading above the graph here. So let's think about this equal sign. Instead of saying equals, it would have been just greater than, because it's dashed, so it has to be not equal to, and it's above it, it's greater than it, greater than the y-intercept. So this would be greater than. So let's see what we have. This guy looks close, but it's got the wrong inequality. This one, not correct. There we go. So we got the letter B. Okay? Remember that the greater than is going to be dashed. Greater than or even less than is dashed. If it was equal to, then it would be solid. Okay? Over a 10-year period, the number of fish in a pond has increased from 250 to 800. What is the average rate of change? So how much was it changing every year, the average rate? Since we're doing a 10-year period, the rate is every year. So we're going to figure out how much it's changing every year. So we're going to start out with 800 and figure out what that difference is. So it has changed 550 additional fish. That's how much is in the pond. We're going to take that 550 additional fish and we're going to split it up all between the 10 years, and we're going to see that we would have had about 55 new fish per year. So as long as you weren't pulling more than 55 fish out a year, you're going to be growing over time. 55 fish per year. Give the equation the best fit line. So with this, we're going to use our calculator. Okay, so we're going to bring our calculator over, and we're going to go to Stat. We're going to edit. We have no values in there. If you have values in there, you can move your cursor on top and hit clear. Probably clear and enter. That would get rid of the values in that list. Do not go up on top and hit delete. So for our x values, we have 0, 1, 2, 3, 4, 5, and 6. For the y values, we have 18, 15, 12, 16, 13, 20, and 22. So those are our values that we have, and now we want to figure out what line is going to best go through those. So we go back to Stat. We're going to go over to Calc for Calculate, and we're looking for the linear regression, the best line that fits all of those. It's called regression when we try to match to the points. So your screen might be a little bit different than this. It might show 4 or 5 different lines. You just want to work your way down to the bottom. You want to be sure that it says L1 and L2 if you have your data in there. So this is telling us that my A value, or my slope, is 0.82. That's not this one. That looks like this guy. Neither of these have a slope of 82. And a y-intercept of 14.1. That would be that one. That would be our B value. The B answer. We're going to solve this equation for x. We've got to get the x all by itself. Sometimes that's confusing. People start to do some crazy math. What do you recognize would be a good step to work with first? Sometimes there's more than one option. I'm going to distribute the 8 and the 4 in. I don't really see much difference that you could do there. So we have 8x minus 24. Then we have the plus 2. We have the 4 plus the 4x. We can combine our like terms. Now we're going to go on opposite sides of the equal sign now. Subtract 4, subtract 4. And then add 22. And divide by 4. And that's going to give us 26 divided by 4, which is also 13 divided by 2, and some people might call that 6.5. This is starting chapter 3. What is the solution of the linear system? A system is where two equations, two graphs, are crossing each other. We want to know what values of x would make this true. There's multiple ways to do it. We could graph it. We could use substitution. We could use elimination. And in some classes they teach using matrices. We're going to go in here and we're going to work on elimination. I typically like that way. So I'm going to multiply this top equation by whatever gets my x's to cross out. I need this coefficient to be a positive 9. Then when I add them together, I have a positive 9 and a negative 9, which makes 0. So I'm going to multiply all three of those by negative 3. That gives me 9x, gives me negative 12y, that gives me negative 18. And then I start to notice Oh, that should be negative 9. Negative 9, positive 12, negative 4. That these are crossing out. These are crossing out. That means there's nothing left over here. And this makes some silly number of, it looks like negative 22. Well, does 0 equal negative 22? And we can put a little slash sign through there. So 0 does not equal it. So we would say no real solution. Okay, that's a no solution. That would mean, most likely, or definitely, that these two lines are parallel to each other. They cross the x-axis, the y-axis, have different y-intercepts. They cross at different locations, but they're never going to cross each other. So there is no x and y that's going to make these two equations the same answer. So here, it looks like I can multiply the top equation by 3, and that'll get me to cross the x's out. So that's 6x, that's 18y, and that's going to be a negative 15. Multiply the first term by 3, 3 and 3. I now have a negative 6. That was my goal. I wanted that to cross out. This is negative 18y. Oh, that's crossing out again. And then 15. So in this case, they all cross out. So this time I get 0 equals 0. If you have 0 equals 0, that is showing that the two equations are right on top of each other. They're the same equation, actually. They're just multiplied by a different amount. So they are the same. Every value that works in the top equation will also work in the bottom equation. So that's an infinitely many solutions. Anything that works with the top one will also work with the bottom one. Okay? Infinite number of solutions. So this is starting page 4. What is the solution of the following system? So the same idea. In this case, though, we see how the coefficients are just 1. So it might be pretty easy if I take the x and I subtract over the y and I leave the 30 there. So I'm going to use substitution. So my x value is going to be negative y plus 30 is going to go in for the x. 6 times x, so if this is your x, plus 8y equals 200. We can distribute across. 6 times 3 is 18, and then the 0. Negative 6 and a positive 8 gives me a positive 2y. Plus 180 equals 200. Subtract the 180 across. So that gives me 2y equals 20, and y is going to be 10 when I divide by 2. So my coordinate for y is 10. Now I can plug that back into my other equation here and say x equals negative y plus 30. X equals negative 10 plus 30. So x would be 20. So my coordinate, they're going to cross at 20, 10. Some story problems. Kayla's school is selling tickets to an annual dance competition. On the first day ticket sales, the school sold 3 senior citizen tickets and 5 children tickets for a total of $70. The school took in $216 on the second day by selling 12 senior tickets and 12 child tickets. Find the price of each senior citizen ticket and the price of each child ticket. So to work this one out, we've got to set up our variables. So we're going to let x equal the cost of a senior citizen ticket. What do they have to pay? And then the y is going to be the cost of a child's ticket. Okay, so what are the two equations we see? Coming back to read it a second time, we see 3 senior citizen tickets. If x is senior citizen, so 3 x's and 5 y's, because y is your children tickets. And from that, we got $70. Another option is to get $216 by selling 12 of the x's and 12 of the y's. Since this has 2 variables, we have to have 2 equations. That's a good hint process for what you need to do. So I'm going to multiply through by 4 to all 3 of these. So that's going to give me negative 12x, give me negative 20y, and give me negative 280. 4 times 7 is 28, and then an extra 0. My other equation was 12x. I wanted those to be the same. That was why I picked negative 4. 12y. So those cross out. It leaves me with a negative 8y. And when I do the math here, I'm getting, when I subtract that down, negative 64. So I divide by 8, negative 8. So I figure out that each y, each children ticket, is going to cost $8. Now I'm going to plug that back into either equation. 3x plus 5 times 8 should equal 70. 3x plus 40. Subtract the 40 across to get 30. And it looks like each senior citizen ticket is costing $10. So in this case, senior citizens are paying more. So we'll call it the senior tickets cost $10, and the child ticket costs $8. Here's another. Ming and Carlos are selling cookie dough for the school fundraiser. Customers can buy packages of chocolate chip cookie dough and packages of gingerbread cookie dough. Ming sold 8 packages of chocolate chip cookie, 8 packages, I'm sure I get this right. Ming sold 8 packages of chocolate chip cookie dough and 12 packages of gingerbread and made $364. Carlos sold 1 chocolate chip and 4 gingerbread and made $93. Find the cost of each one. So, you got to start out with defining the variable. Let x equal the cost of the chocolate chip cookie dough, and y equal the cost. Try to be specific. It's the cost. It's not chocolate chip. It is, because that might be how many chocolate chips. This is the cost. This is the cost of the gingerbread. So we saw that Ming did 8 chocolate chips and did 12 gingerbread and made $364. It's a pretty good fundraiser. Here, did 1 chocolate chip, Carlos did, and 4 packages of gingerbread and made 93. So you could do this a couple different ways. We could try to get our x's together by multiplying by 8, by negative 8, but that's going to make 93 times 8 could get pretty big. So in this case, let's multiply this guy by negative 3, and I'll try to get the y's to cross out. So I'm going to start out with my 8x, my 12y, and my 364. I'm going to multiply this one by negative 3. 3 times 1 gave me negative 3. 3 times 4 gave me negative 12. And 3 times 93 gave me negative 279. So this subtracts to be 5x. These cross out, which is what I was trying to do. And here I get 85. So divide by x, and I'll get 17, or divide by 5, and my x equals 17. Now I plug it back into either one of the equations. So I'm going to look at 8x. Well, I don't want to do 8 times that. Let's just do x plus 4y equaling 93. So that's 17 plus 4y equaling 93. Subtract the 17 across, and my 4y is going to be 76. Divide by the 4, and y is going to turn out to be 19. So if chocolate chips cost $17 and gingerbreads cost $19, that's how you could reach these amounts. Alright. Number 6. Which of the following graphs represent the solution of this system? Here are 2 equations. We're graphing them to try to find the solution. So, a couple ways. We could take the intersection of each one, plug those in, and see if they work. We could take this equation here and say that y would have to equal negative 4x plus 8. So I know that it's got to cross up at 8. 1, 2, 3, 4, 5, 6, 7, 8. So this graph kind of looks like it's doing that. It's increasing by 1, 2, 3, 4. Backwards 1. No, that didn't quite reach. So I don't think it's going to be A. Here, 1, 2, 3, 4. The slope doesn't seem to fit. It's got to cross at 8 and have a negative slope. Let's see, I didn't get either one of those to work. Okay, let's come back, and if you notice from their intersection, 1, 2, 3, 4, that does have a slope of 4. So if we went up 4 more, that'd be 6 over 1. Up 4 more, okay, one more time. We're here at 1, so 1 plus 4 is 5, and our 5 plus 4, not working again. Okay, I don't like doing it that way. I'm going to multiply this guy by negative 2 and see what happens, because I'm not coming up with an answer. We'll just go back to the old way of doing it by elimination. It would be 6. And negative 36 the x's cross out. I get negative 5y, and I get negative 38. Oh, a negative and a negative. Man, I'm messing this all up. Make a positive, so that would be 7. So when you divide, that would be 28. Man, glad this is the last one. So y equals negative 4. So 1, 2, 3, 4. That does look to be in line there. This one does not cross at negative 4, does not cross at negative 4. 1, 2, 3, 4. This one does also. So let's take our negative 4 for the y and plug it into the other equation. Add that across to get 12, so x equals 3. So negative 4, and that was getting funny answers again. So yeah, here x is positive 3 and y is negative 4. I did it. That was a problem that was way easier than I made it. Enjoy.